Good morning to everyone. This is Sultan, Assistant Professor, Department of Aerospace Engineering, Sanjay University, Kolhapur. In this lecture, we are going to see about that Illities, which is in that the avionics system. So, what is meant by that Illities? So, Illities will have that major Illities of avionics systems are capability, reliability, maintainability, and certificability and survivability and availability, successibility, and vulnerability, and life cycle cost for military aircraft, and cost of ownership for civil aircraft, and technical risk, and weight and power. So, capability. So, capability means how capable is an avionics system and can they do the job and even more. So, if you have some missions, that equipment is capable to do or not. Designer to maximize the capability of the system within the constraints that are imposed and reliability. Designers strive to make the system as reliable as possible. For example, that mission is possible to do that segment. So high reliability, less maintenance cost. If less reliability, customer will not buy it. And in terms of civil airlines, that certificating agencies will not certify that the equipment. Maintainability. So closely related to the reliability, system must need to preventive or corrective maintenance. System can be maintained through built-in testing, automated troubleshooting, and easy access to hardware. Availability. Combination of reliability and maintainability is called as the availability. So trade-off between reliability and maintainability to optimize availability. So availability translates into sorties for military aircraft and into revenue flights for civil aircrafts. Certificability. Major area of concern for avionics in civil airlines. For example, if you're taking any component in the aircraft, that should be certified by the agencies. So, certification conducted by the regulatory agencies based on the detailed expert examination of all facts of aircraft design and operations. The avionic architecture should be straightforward and easily understandable, and there should be no sneak circuits and no novice modes of operation. Avionics certification focus on three analysis: preliminary hazard, fault tree, and then FMEA. Survivability. So it is a function of accessibility and vulnerability. Accessibility measures of probability that an aircraft will be hit by a given threat. Vulnerability measure of the probability that damage will occur if there is a hit by the threat. Life cycle cost, that is LCC or cost of ownership. It deals with economic measures need for evaluating avionics architecture. It includes cost of varied items as spares, acquisition, transportation, storage, and training crew and maintenance personnel, hardware, development and test, depreciation and interest. Risk. Amount of failures and drawbacks in the design and implementation. For example, if you are taking any one of the electronic system, it should be getting failure, but how much of the risk it should be if in case it is failure. Overcome by using the latest technology and fail-proof technique to be overcome both development and long-term technological risk. Weight and power. Minimize the weight and power requirements are two fundamental concepts of avionic design. So whenever going to design one component, that weight and then the power consumption should be reduced because our aim of the aircraft should be reducing the weight. So the design must be lightweight and power consuming, which is possible through the data bus and the latest advancement of electronics data sets. So integrated avionics weapon systems. So in that aircraft, integrated avionics weapon systems are sonar, radar, military communication, and electro-optics, and ECM or ECCM and ESM and DAS tactical missile guidance. So head glass cockpit. So what is meant by that head glass cockpit? The term glass cockpit generally refers to an LCD display that replaces the conventional six-pack of flight instrument. So previously that aircrafts are seen that the six-pack conventional systems, which will be as an analog type, that all the analog types displays will be replaced by that the LCD display that is called as the glass cockpit, head glass cockpit. So it is a term given to any aircraft in which the primary instruments are located within a single primary flight display (PFD) and multifunction displays (MFD) that looks like a computer screen, a large flat glass panel display. So it has some advantages as well as the disadvantages. Then for analog type, we don't need that any power consumption. For that the digital all displays, we need that the power consumption. So PFD and MFDs have the capabilities to display all the traditional instruments along with lots of additional data such as engine data, checklist, weather and traffic displays. The diagram indicates the six-pack conventional instruments. Conventional instrument that is called as a six-pack conventional instrument. The typically six-pack on Voltray aircraft includes six primary instruments, hence the name is six-pack. Airspeed indicator, attitude indicator, altimeter, vertical speed indicator, and turn coordinator, and directional gyro, that is DG. These are the six instruments we called as a six-pack conventional instruments. So these are the six-pack conventional instruments. First one is that airspeed indicator, and then second one is attitude indicator, third one is altimeter indicator, and fourth one is vertical speed indicator, fifth one is gyro direction indicator, sixth one is turn indicator. In a glass cockpit like the popular Garmin G1000, these instruments no longer that exist and the data is displayed digitally. The first one is the Garmin G1000 company only introduced that the glass cockpit. The General Aviation Manufacturer Association (GAMA) starts to define a glass cockpit by defining that they call an integrated flight deck. Integration may also include display and control of airborne surveillance, airplane system, and engine systems. GAMA's definition of an integrated flight deck states at a minimum an integrated cockpit flight deck must include electronic displays and control of primary airplane, airspeed, altitude and attitude instruments and all essential navigation and communication functions. FAA rules. The FAA does not define the term glass cockpit, but the organization that define a technically advanced aircraft or TAA as having a IFR certified GPS or an MFD with weather, traffic or terrain information and an autopilot. The Garmin G1000 equipped aircraft falls into a class of aircraft configuration referred by the Federal Aviation Administration as technically advanced aircraft or TAA. And whenever have that advantages as well as it has a drawback. So today aircrafts have multiple interdependent electronic displays that work together to give the pilot all of the necessary data on one screen. These glass cockpits are meant to more efficient for pilots but can cause some problems if the pilot is unfamiliar with the onboard system. So the pilot first of all have to take training of the all the advanced equipments. Problems can arise for pilots who fail to become the completely familiar with the glass cockpit technology and spend too much heads down time instead of the cockpits figuring out of the computer functions. So, on too much heads down time, even a problem for pilots experienced with the technology, as they can easily become overly dependent on it or fixate on its function instead of looking out at the window.